Hello guys and welcome to today's video, which is about nth term and sequences. So in this video we're going to be looking at what we call arithmetic sequences, okay, and spotting patterns in sequences and finding the nth term, okay, where appropriate. Okay, so example 1. So this is my sequence 1, 2, 3. So a sequence essentially is a pattern of numbers, okay, so like with a comma here, essentially, so this is what I call a sequence. Okay, so we can clearly see here that we are adding 1 each time. Okay, adding 1. So here is going to be 4, because 3 add 1 is going to be 4. 4 add 1 is going to be 5. Adding 1 again. Okay, so plus 1, plus 1. Okay, so these are going to be my sequence. Okay, so this is the answer to the first example. Okay, next example. So it says fill in the blanks. So we've got 2, 4, 6. Okay, so each time I'm actually adding 2 each time. Okay, so adding 2. So 6 add 2 is going to be 8. 8 add 2 is going to be 10. 10 add 2 is going to be 12. 12 add 2 is going to be 14, and then finally it's going to be 16. Okay, so I'm adding 2 each time. Okay, so this is actually a sequence of actually even numbers, because it's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on and so forth. Okay, so if you're interested, the nth term for this will actually be 2n, and the nth term for this would just be n. Okay, n or 1n, okay, if you're interested. But we will come back to this like in this video later today, if not another video. Okay, so the next one, right, so it says fill in the gaps. Right, so I've got 3, 7. Okay, so I've added 4 to get there. I'm going to add 4 again. Okay, so that's going to get me 11. I'm going to add 4, I get 15. I'm going to add 4, I get 19. Add 4, I get 23. Add 4, I get 27. Okay, so this is a sequence, okay, again, that has all odd numbers, because the idea here is that when I add an odd and an even, I'm always going to get an odd as my answer. So these are going to be all odd numbers. And the nth term for this, if you're interested, okay, so because I'm adding 4 each time, that's where I get this 4n. Okay, so this is where the 4n comes from, because essentially I'm adding 4 each time. So it's implying that I'm following the 4 times table. Okay, but the 4 times table actually generates a sequence of 4, 8, 12, 16, 20, and so on. But my sequence is 3, 7, 11, 15, 19. So I'm actually subtracting 1 there. So it's going to be 4n minus 1. Okay, because I'm going from 4 to 3, so I'm minus 1. 8 minus 1 is going to be 7. 12 minus 1 is going to be 11, and so on and so forth. So to go from this sequence, which is a sequence for 4n, and then this one's going to be 4n minus 1, okay, because I'm minusing 1 there. Okay, right, next example. Okay, so last 2 examples. Okay, so here I'm going to be adding 4 again, adding 4, okay, add 4 and add 4. So 9 add 4 is going to be 13. 13 add 4 is going to be 17. Okay, so again, adding 4 is going to be 4n. Okay, so 4n obviously is going to be the sequence 4, 8, 12, okay, 16, 20, and so on. Okay, but if you look here, okay, we've got 1, 5, 9, 13, 17. Okay, so it's actually gone down by 3. So it's going to be 4n minus 3. Okay, for that one. Right, the final one now. Okay, so I'm going to add 3, add 3. Okay, so that's going to be 13, 16, and 19. Okay, so adding 3 means it's going to be 3n. Okay, so it's following the VV3 times table. So whatever I add here, my common difference, that's the number that goes in front of n. Okay, and then we know that 3n is going to be 3, 6, 9, 12. Well, we want 4 for the first term, so we're going to add 1, because 3n will be 3. Adding 1 will give me 4. Okay. Or if that's a bit confusing, what you can do is work out what the previous term is. So 4 minus 3 gives me positive 1. Okay, so that's actually my common difference, if that makes sense. So that's like another way, obviously, to get our answer. So to work out this extra bit here, you can work out what the term is before and use that to plug on the end of your answer. Okay, so thank you for watching my video. Okay, and look out for some more videos.